I'm a member of the ALICE project, which is based here at Carnegie Mellon. As many of you know, ALICE was founded by Randy Pausch, who is professor of computer science and human-computer interface, probably best known right now for the last lecture. He started the ALICE project years ago with a lot of different motivations involved. What's significant about Randy was his contribution, I think, to trying to bridge technology and the arts. And that, in fact, as sort of a physical manifestation of that connection, the new computer science building that's being built here on campus is being connected to the Arts Center, the Purnell Arts Center here on campus, by the Randy Pausch Bridge. All right. It was something that he was deeply interested in. His best-known course here, Building Virtual Worlds, is a course in which he combined technologists and artists together to build cool things. And it wasn't in the service of trying to convert the artists to technologists. It wasn't in the service of trying to convert technologists to artists. It was, in fact, trying to find ways in which both these disciplines could work together and engage each other and come up with just great stuff. When ALICE originally was developed, it was designed to approach the problems that Golan illustrated so well. In fact, I used to have a slide like his in this presentation about the dropout, the declining enrollments in CS, the loss of women. And so the game plan for ALICE was to use graphics to help students in their first computer science experience to develop an intuitive understanding of basic computer science concepts. It wasn't, or programming concepts specifically. I shouldn't say computer science because there is a distinction between programming and computer science. But as part of the first introductory programming experience, you know, it was Randy's and the ALICE team's insight that by using motivational, engaging objects to be manipulated on the screen, that we could, in fact, be able to start teaching some fundamental concepts that would help students understand what it is they were getting into as they started approaching the more traditional kinds of approaches and tools used for teaching computer science. The idea behind ALICE was this was not going to be a CS1, which is the traditional first course, college level, but instead a sort of pre-course for this, an exposure. Sometimes it was taught in a mini format, sometimes it was taught in conjunction with an already existing CS1 course, sometimes it was taught as a semester before. But that it was, in a sense, an attempt to plow the ground for students to help them get comfortable with what was going to lie ahead. So let me show you very quickly what ALICE 2 can do. I'm even going to build a quick world.
We're going to dance till the cows come home. Hit it at first.
Destination unknown. Destination unknown. Destination unknown. Destination destination unknown.
All right, and so one side, Alice, there's two sides to the Alice coin, and one side is sort of building this kind of music video or story project, program, show, story, and what's involved here is that there's looping, and you have to build methods to teach the cows how to dance. You know, there's a lot of programming concepts that are involved. As students are trying to do something to amuse themselves and to amuse their peers. Another world, the other side of the Alice coin would be the Frogger game. And I can't do this demonstration anymore without thinking of George Costanza trying to move that machine down the streets of New York. But this was developed by a student community college. And I'm never generally very successful in playing the game. But then sometimes I get it figured out. Audience, I missed. Okay, but it's this, you know, so that now there is also this interactive component for Alice, in which students can build games such as this. You know, and what this does is this sort of attracts two different audiences. There are, you know, of course, we all know that the boys and the love of games, you know, and the gaming element tends to attract the boys. But we have discovered in our work that storytelling, you know, is very important for women, particularly young women. You know, middle school girls have stories to tell. They have ways, and the way they process a lot of events in their lives is by telling stories, by talking to other people, by, you know, why doesn't he like me? Kinds of things. And so that by having both of these kinds of possibilities, you know, in the tool, we find that you know, we're able to diversify the students and engage more of the students at all levels. Oh, one more thing I wanted to show. There are, as always, and I'm sure that you find this in the arts community when you start talking about technology and the arts. Well, that's not really computer science. That's not really programming. So to satisfy that audience, it is also possible to solve with Alice some traditional computer science problems, such as the 8 queens, or as we like to say, the 8 chickens problem. Which essentially what this is it's a classic computer science problem in which you are trying to find how to position 8 queens on a chessboard so that they do not attack. No one queen is attacked or attacks any other queen. And so this is a brute force solution. There's certainly more elegant ways to solve this problem. And yet it deals with concepts like recursion, you know, backtracking, and it's something that we can take to computer scientists and say, hey, you know, we can solve the problems that you're interested in as well. You know, that Alice does not necessarily have to be considered a toy. Okay, it's not necessarily designed to teach a whole course. I wouldn't recommend doing the whole CS1 curriculum in Alice. But yet it is a rich enough environment that you can do some very interesting and engaging things. So, the Alice software, as you saw, uses 3D graphics to engage the students. We use a drag and drop editor to prevent syntax errors. It turns out that there are 4 things that when I walk into my first CS1 course, and if I was to do a traditional hello world kind of problem, there's 4 things the students have to learn right away. I smack them upside the head with this. First of all, just the notion of what a computer program is. What's the programming concept that I'm trying to illustrate? All right. Secondly, the syntax issues. All right, semicolons count, parentheses count, braces count. All right, there are certain magic words you have to use, and they have to get comfortable with that. You have to get them comfortable with the development environment you're using. You know, are you using just a basic text editor, or are you using you know, something more powerful industrial strength, such as an Eclipse or a NetBeans? All right, they have to be able to interact with them. And then finally, it turns out that students no longer understand the operating systems. They don't know where files are saved. Okay, I have this document, I just save it in my documents. If they don't know where my documents is, they're lost. You know, and so you wrestle with this. And if Randy used to like to say one hard problem at a time. You know, and so what Alice really isn't trying to get rid of the syntax problem. Syntax is there, has to be dealt with, has to be recognized. But it's our position that we don't have to do it on the first day. If what we want them to do is just get comfortable with some basic computer science concepts, get comfortable with our IDE, which tends to be very intuitive and easy to manipulate, then we sort of, you know, we smooth out or lessen the learning curve. All right, not to you know, not to hide things or dumb down the curriculum. We're not interested in that. You know, but we are interested in finding ways to help students learn, to be supportive as opposed to an opponent in the learning process. So, let's build a quick Alice world, the equivalent of our Hello World. When you launch Alice, you have a choice of different environments. We also have some examples, a tutorial to work through. But so I'm going to start off with the grassy ground. I need to add 2 objects. I have Alice comes with more than 400 pre-built objects that students can manipulate, either in here or there's some also at our website that students have access to. So I want to bring a monkey. Turns out, members of the Alice team, we all have our favorite characters. Wanda Dann, who's the director of the project now, she loves the penguin. She builds penguin worlds. I've always been a big monkey fan, so I build monkey worlds. And then I'm going to bring in a biplane. And what I want to build here is a wing-walking monkey. I want to be able to put this monkey up on the wing and do some tricks while it's flying. All right? So I have the biplane, and I can manipulate the objects by dragging them around. I also have a tool button over here that will help me. All right, I need to elevate or get the plane off the ground. I may want to rotate it a little bit so it's more in parallel to the camera. I need to get the monkey up on the wing, but he's still turning, so I'm going to push him back and try and raise him up. And I still don't think he's there. So what we have here is a quad view that will allow me to zoom in or zoom out so I can see the character, to get different perspectives. Okay. Pull in, drag it, pull in a little more, drag a little bit more. I see the monkey isn't where I want it, so now I can grab the monkey, position it over essentially the target area, turn him so he's facing pretty much forward, but I still don't know for sure if he's actually on the plane or floating above it, so I can go to this view. Oh, it wasn't doing anything, zooming. It looks like he's a little bit above it, so I'm just going to position him down, and now I'm convinced he's on top of the wing where I want him. All right, so I've built the scene, and I want the biplane to fly, and so every object has behaviors, methods, associated with it. And so I want just the biplane to move forward. So if I tell the biplane to move forward 5 meters, well, it does that, but it leaves the monkey behind. I need the monkey to be able to travel with the biplane. And so one thing I can do, Alice has this construct that really doesn't exist in Java, but we find very useful, called a do together. So I can tell the biplane to move forward and also tell the monkey to move forward 5 meters, so that in parallel that they move together. But I'm losing it. My camera isn't tracking with it, so I'm going to have the camera move to its left 5 meters as well and play. Okay, and so it looks like, but you can see that there's some interesting effects going on that I can play with here. But in some sense, the plane and the camera are not tracking together. I don't have the camera oriented the way I want necessarily. So, I can continue and then try and work with all these things as, and just whatever I do with one, play me and my shadow. If I make the plane do something, make the monkey do something. But it turns out in Alice we were able to set properties so that I can tell the monkey that I want its vehicle to be the biplane, the entire biplane, and in fact I can tell the camera that I want its vehicle to be the biplane. And what we mean by this is just simply, if you get in a car, the car is your vehicle, and if the car goes, you're going with it. All right, so we're just saying exactly the same thing right here. That when the biplane goes, it has 2 passengers, as it were. It has both the monkey and the camera, so that now I can come back to the biplane, and I can tell the biplane to move forward 10 meters, play, and so that now they all track together. So far so good. I got the plane flying, the monkey staying on the plane, the camera's keeping the monkey in view. What I want to do is now I can make the plane fly straight for a long distance, all right, and track like this. But what I really want is, because I want some interactivity, I want to be able to, tell the monkey to jump or something like that, or do a somersault. I really need to just get the plane in motion and keep it in motion all the time. Essentially the equivalent of an event loop. And so the way I'm going to do that is I'm going to use the while construct and pull it up here, and I'm just going to say while true, which seems to be the classic formulation for an event loop. While something is true, the plane is going to move. But I really don't want it to move, because I'm going to use another old-time movie technique from silent films and early industry. Instead of having the plane fly straight, I'm just going to have the plane circle the camera. I'm going to have the camera track it. So it looks like that the plane is moving forward. But instead, actually what's happening is it's just going in a circle around the camera. So I no longer want to use the move method. Instead, I want to turn. And I'm going to have it turn, have the airplane turn, and this is where the students stand up and they start going, okay, left or right, which way is it going to turn? And I'm going to have it turn left a whole revolution. Now, if I do just that, okay, well, it looks like the ground is spinning underneath it, all right? And that's because the camera is still the vehicle thing. So the camera is turning with the, it's actually, well, best way to illustrate it, and that's what's great about Alice, that instead of trying to describe what the problem is in sort of abstract terms and so forth, you can say, all right, what happens if I take the camera's property and set it back to the ground? And then, oh, that's what's going on. Now you can see, okay, that's what the problem is. The plane, when it's turning around its center. It doesn't know what to turn what it should be turning around. And so what I'm going to do is I'm going to tell the biplane to turn left 1 revolution as seen by the camera, which means that it's now using the camera center as its point of reference to turn around. And I'm going to reset the camera's vehicle back to the biplane. And so now I click on play, and now, and so now I am tracking. It looks like it seems a little more realistic. You can even argue, oh look, it's flying under clouds and stuff as the lighting changes. It still looks a little stop and start-ish, and that's because Alice by default assumes real gravity at some sense, and at least in terms of forward motion. If I was to start walking up the stairs, normally I'm not going to start at full speed, right? There's an acceleration phase, and then as I near the top, there's a deceleration phase. And Alice is assuming that as well. And so what I want to do is I want to change the style from this gently start, gently stop thing to abruptly. So that, you know, my motion now does start completely full speed. What's going on? Stop abruptly. Okay, it has smoothed it out, so now it looks like continual flight. So far so good, but the monkey isn't doing any tricks yet. So I'm going to raise the camera a little bit. So we have camera control tools down here that will allow me to either come forward or to raise up and so forth. So I, just raise my camera a bit. Oh, look, I'm supposed to be here. So what I want to do is I want to teach the monkey how to do a somersault. So I'm going to create a new method for the monkey called somersault. And in that somersault, the monkey is going to move up, let's say 1 meter, turn forward, a full revolution, and then the monkey has to move down 1 meter. All right? And then, so I want to make an event with this. So what I'm going to say, I'm going to create a new event, and when a key is typed, any key, I'm going to say, give me the letter S. The monkey is going to do a somersault. All right, click on play, type the letter S. Type the letter S. Okay, so now I have a wing-walking monkey. And, sound is really engaging. So students really love to add sound to their worlds. So the mouse is clicked on the monkey, the entire monkey. We're going to have the monkey screech, which is a sound that's actually built into the Alice monkey. That's not something I did beforehand. So it's not my screeching you're going to hear. So the somersault, click on the monkey at the same time. Which seems to be what the monkey would be doing if we were making it do this on the bike. All right, so that's, that is sort of the first programming experience, the code itself. Now, maybe we get to the while true in the event, that may be pushing it a little bit more, but it is, it's not necessarily a difficult world for students to understand or to think about. And then the assignment might be, okay, now teach the monkey to do other tricks, and go from there. The objects are obvious. We try to make everything visible, which includes the mistakes. If I was to tell the monkey to somersault forward, and in fact it spun sideways, you know immediately that I've done something wrong. Instead of turning forward, I've turned to the right or turned to the left. It's very easy to catch and understand what your logic errors are in the program. All right. I think a key element, and for anybody who's developing software to be used in an educational setting, something that I really think helped Alice take off was the fact that not only did we have a cool piece of software, but that we had pedagogical materials to support that software. There's a lot of great tools out there. There have been a lot in my lifetime. There's been a lot of great tools that have been developed. But sometimes people put the software out there and expect that the masses are going to find them, you know, or more importantly, the masses are going to figure out how to teach them. But as you all know, your lives are busy, and sometimes having something out of the can to get you started, having sets of PowerPoint slides and quizzes and syllabi and everything helps. You know, because given that, as you're trying to figure out how to teach with this thing, and it is new for the people, it's good to have the guidance as, okay, this is one way to do it. And then, as you gain experience and confidence, you start to think about, okay, but I want to do it this way. I want to change this. All right, and so Steve Cooper and Wanda Dann came to Randy and said, you know, you got this great tool, and we've been working on this book, and we have this book, and we think that together, you know, we can do, you know, we can really make this a very useful tool. You know, and I really recommend any of you who are working on this really nifty tool that's out there, go and find some teachers to work with you to help you develop the pedagogical materials to support it. Because particularly if you're attacking the high school and middle school market, you know, they don't have time anymore. They're so busy in crowd control that they really cannot take time to take just a piece of software and develop their whole course from it. Alice 3, and I'm not going to talk too much about it because that's not really the focus of this conference. Alice 3 was developed to bring Alice to a CS1 course. You know, I got involved with the Alice project several years ago because I found Alice 2 and I said, I want to use this in what's our 15100 course here on campus. It's our first introductory course for beginners. And I wanted to see if I could use Alice. And it turns out that Alice 2, the transition from Alice 2 into Java was very difficult. Not because of syntax issues necessarily, but because the Alice 2 view of objects is different than the Java object. You know, I taught the monkey how to do a somersault, but only that particular instance knows how to do a somersault. I bring another monkey into the world, I have to reteach it. You know, and those of you who are familiar with object-oriented programming, that's not the way it works. All right, and so there were other issues involved with that transition. Fortunately, while I was wrestling with these issues in my class and finding out what was going on, Wanda Dann was here on sabbatical. Randy, of course, was down the hall, and so I became an irritant, going, "Well, this isn't working. You know, what am I supposed to do with this?" And I'm not going to say I'm the motivator because I think they were already thinking along this path and started to head down this path. At the same time, Dr. Caitlin Keller, who was a PhD student for Randy at that time, was doing research on the middle school side, and she was saying, well, yeah, great, you got this great tool to teach people how, you know, to make programming easy, but, you know, why do I care? You know, why should students care? What's motivating about it? And particularly for middle school students, younger students, she found that, you know, teaching just animation wasn't cool enough. Not everybody wants to, you know, be their own Pixar studio, but instead they want these sort of higher level animations, such like the monkey already knows how to screech. I don't have to worry about recording my voice and screeching and then, you know, importing it somehow into Alice. And so Caitlin built a series of models that had much higher level animations, you know, and that students were able to use those animations as motivations for storytelling, so that if the cafeteria lady knows how to brainwash students, what's the story you write around that to motivate that behavior? If you have a robot that knows how to crazy go nuts, all right, well, what's going to make a robot go crazy, you know, and go nuts? You know, and so out of that, we were able to start doing things using the Sims from Electronic Arts. Now, we're probably violating copyright. You may not be able to show this. But I found Pixar has some great comparables for programming. This is the short film Lifted. And this is now my Alice 3 Hello World. I start off by showing the students the first part of this. And then there's your programming student. Trying to figure out how to solve the problem. And so what we do, what we do in my first world, the first assignment is show them that, and then we go into Alice 3, and their assignment is essentially to get the sleeping Sparky out through the window, just as the other alien student was supposed to do. And we're able to take advantage of pre-built animations that comes with the Sims library. All right, to do which the students find motivating. You see that Alice 3 looks very much like Alice 2, but it has some significant differences. And now suddenly we're talking about this dot. And so forth, new angle and revolution, the word new, this version is definitely geared towards a CS1 audience, and I'm not sure that it is the right tool for at this time for someone who's just doing an introductory level, just first experience in programming. Along the way, we discovered students are different. Students mediate their lives through technology. The students that I'm working with now are different than the students I worked with 10 years ago, and they're certainly different from when I was a student. This was brought home to me in watching the inauguration festivities and watching the Obama children. Here these children are, they're sitting up on the dais as their father's being sworn in, and they're recording it. It's not enough now to just be in the experience and to have the experience, but somehow you have to be able to prepare yourselves in a way to share the experience. All right, and students, the technology makes that, it's so easy to just Twitter. This is what I'm doing right now. Okay, students are used to broadcasting their lives and making it public. The other thing that has happened to the Alice team is that in our workshops, particularly last summer, we suddenly started engaging with teachers at the high school and middle school level who were not technology teachers. They were, in fact, language arts teachers and math teachers and physics teachers, science teachers, language teachers, who saw Alice as a way in which they could engage their students to build, not worrying about programming things, but just as a language arts assignment, build a movie trailer to promote your book report. All right? Okay, you have just learned about Egypt. All right? Give us a guided tour of Egypt. All right? And so that now suddenly we have these non-technology teachers who are finding ways to use a tool like Alice that's become accessible to them to be able to engage the kind of students that we're now working with. Okay? There is a great tool, and I really don't have time to show the whole thing. Dr. Michael Weir, I believe, out of the University of Kansas, the Digital Ethnography Project, is looking at how students, particularly at what he calls the YouTube generation. All right, it is worth going and looking at them to illustrate how our students are different. It's what did I do? I jumped out where I didn't want to jump out. All right, but for my students, 49% do get assigned reading, 26% of them find it relevant. They will read 8 books in a year, but they'll read 2,300 web pages and 1,281 Facebook bios. They may end up writing 42 pages in a class, but 500 pages of email. All right, you look at all the hours, they multitask, they spend 26.5 hours doing all the things that are listed there in a day. They're multitaskers, they're used to being multitaskers. They're collaborators, they expect to be able to collaborate. The way children are being raised now, I don't know, you know, and I'm speaking as someone, you know, with a little more age than most of you here in this room. It is now, children are partnering with their parents, or parents are partnering with their children in their being raised, in their development. All right? It's not as it was in my day where my parents knew best and, you know, father knows best, right? Now, you know, there's a partner collaborative relationship that starts from very young, and students expect that kind of collaborative relationship. And so I think to engage our students, we have to find ways to bring that into our teaching and into the tools we provide to facilitate teaching. I could go on. All right, but this is, I think, we believe that as Alice goes forward, Alice is going to have to be able to export scenes to YouTube and to cell phones and to Facebook. All right, that we have to support the development. Scratch is the leader, as far as I'm concerned, in this notion of how to develop a community. You know, we like good ideas, and we're not afraid of stealing good ideas, particularly, and you know, with proper attribution. If you haven't seen the Scratch community, you've got to go check it out. You know, it is, you know, we think we have some opportunity with Alice, and with the interactivity that we have. We see that we can build a community, but also then be able to make it interactive, so that someone could post a scene and say, okay, build your Alice character, and with Alice 3, when you can be able to write a character that's a class, and say, okay, how well does your character do in the scene that I've developed? And Alice is also being written in a way that people can write wrappers, APIs, other tools to plugins to the Alice environment, as it were, to support robotics, game engines, databases. Be interesting to see how people in this room figure out ways to use Alice to engage the arts, to support the arts. I'd love to see that. There are 4 things that's going on in the Web 2.0 world. Right now, our sims are Alice worlds, and I'm going to have to wrap up at this point. Our Alice worlds right now are heavily scripted. The monkey followed a very predefined script, very deterministic. All right, you know, there was a little bit of interactivity, and then I could click on and make it screech or hit the yes. But by and large, that world was very deterministic. It was very limited in what that monkey could do. Eventually, we're hoping that worlds can be built, which students build models that can interact with an environment that has been built for them, you know, such as a geocache kind of simulation. All right, I'm going to put, I've built, as a teacher, I've built this world in which I have things hidden throughout it, and students have to write an avatar that can go and find and collect things from that environment. And then the next step is getting the models to interact together dynamically. All right, there's two people in a party room. All right, how do they get to hook up in the best sense of the word? Okay, all right. And then finally, is there going to come a time in which we can build avatars that interact with people on the other side of the wall, break that fourth wall? All right. Something I tell when I speak to students, you know, one thing I've been telling them is that bits don't die. Okay, you're posting stuff on YouTube right now that your grandchildren are going to be able to see. Okay, all you need is some kind of mechanism by which to convert the format that's there now to the format that's going to be there, and that's going to happen. Students right now, grandchildren of students now are going to know their grandparents, going to know you better than you know your grandparents, because they can go and they can look at your Facebook pages, you know, and suddenly there you all are. grandma, you know, the beer bong, you know. But at the same time, what I think what's also going to happen is that people are going to be able to build avatars in which they can pour pieces of themselves, so that someday a grandchild wants to interact with a grandparent who has happened to pass away. You know, if that avatar has links to their Facebook pages and all these digital representations of themselves that have been preserved. You know, we talk about Second Life. You know, in some sense that's what's happening, what's going to happen as we go forward. You know, Alice isn't going to push us there, but Alice is starting to make that kind of stuff a little bit more possible, I guess. All right, I'm done.